Welcome to Heat Treat Radio. Today, we'll be traversing into the future of heat treat with Piotr Zawistowski, Managing Director of SECO Vacuum. This episode was recorded on the ground at the ASM Heat Treat Show with Doug Glenn, publisher of Heat Treat Today, Karen Gantzer, the general editor at Heat Treat Today, as well as myself. Peter first shared how SECO Warwick was on a mission to actualize the future of heat treat.
I think we are on the mission as SECO Warwick, and I am on the mission.
Yeah.
So I think the future of heat treatment will be Lpc for carburizing, and gas quenching for quenching instead of oil.
Okay.
And I think the future is Lpc and hydrogen quenching. And to be honest, but right now most of carburizing is done in the atmosphere, carburizing atmosphere, and most of the quenching is done in oil. So I think that. Everything is moving in the vacuum direction, if you will, but we are not there yet. So that's our mission in general. So I think I showed you once a graph. What is the difference in quenching between oil and gas? So right now with 25 bar quenching, we are on the level of slow oil. So together we have to use helium. Helium is expensive. It's not economical. But we can go to hydrogen, which is the speed of oil. And it's everywhere. It's cheap. So I think this is the future.
This idea that the future of heat treat will be Lpc and gas quenching, specifically with hydrogen, means moving in the vacuum direction, as Peter just noted. But how fast will this transition come, especially given safety concerns with the use of hydrogen as a quenchant?
Exactly, that's the concern right now. So I think it'll come, but we are far away from that. But anyway, we don't have to go to hydrogen, but I think we should go to nitrogen for now, and we have some solutions for that. And on top of it, I think we will go from regular carburizing to Lpc. So it's not easy for people to switch. So our mission, what I told you about, is just to try to convince people to switch to Lpc, and we would like to make it as easy as possible for them. So that's why, like maybe 20 years ago, we thought about it. Let's start maybe from, because we have quenching and carburizing, let's maybe leave quenching the same and start from carburizing. So we developed vacuum oil quench furnaces, just to make it easier for...
So they only have to change one thing at a time.
Exactly. But then we thought, I think it's a big change for them anyway, because those are different oils, and it's a vacuum oil. So right now we're introducing a furnace with vacuum carburizing, but the regular atmosphere quenching chamber and regular oils that all the heat treaters they know for
they've known forever
years.
And ever.
Exactly.
So this is the super?
No, this is the Super IQ.
Super IQ.
This is the Super IQ, and I don't want to make it like commercial, but this is like another step. So if you look at our wall here, so we have like 6 different products, and 5 of them are for carburizing. So they are not. Starts from vector. It can have carburizing. It don't have to be, but anyway, they all are connected with carburizing. So I think the mission is to convince people and to switch the industry from all the messy, dangerous, with open fire furnaces to like new, clean, better technology.
As we just heard, these are big transitions. So if the first step towards heat treat with Lpc is for heat treaters to use atmosphere carburizing with oil quench, what are the next steps to move to a fully vacuum-based future?
Step number 2 is vacuum oil quench, and step number 3 is vacuum carburizing, or Lpc, and high pressure gas quench. So that's the future, in my opinion, and that's the goal. With hydrogen, yes, with hydrogen.
As a review, moving to Lpc could look like first using a traditional vacuum furnace with atmosphere capabilities, then heat treating with vacuum oil quench, and finally heat treating with Lpc and high pressure gas quench. If such a transition is appealing, it would be good to know what the productivity improvements of Lpc are.
So it depends, of course.
That sounds very political. It depends.
Yes. So a couple of factors. First, we would have to take into account what kind of a case depth we are talking about, and so on and so on. But in general, I can tell you that the productivity increase should be like 50 or even 100% or more.
You can double the amount of product through same time.
Yes, and it's simply with increasing the temperature. So we are not limited with low pressure carburizing with the temperature, and there is a limit that atmosphere carburizing can be done. So we have a lot of possibilities here.
So a 50 to 100% increase in productivity and an increased temperature range comes along with low pressure carburizing, or LPC. When considering LPC, there is the question of how traditional specifications, which clearly state the necessity of atmosphere carburizing, can be compatible with this newer technology.
Yes, and those specs are changing.
Well, that was my question. Is that going to be a hindrance?
Yes, it is right now, especially in aerospace. So automotive industry, they moved already to LPC, but aerospace, we are trying to help to change those specs. And they are changing as we speak, because a lot of those specs, they are still from the 80s. So there was no LPC back then. As you know, in aerospace, it's not easy to change a spec, but this is happening right now as we speak.
So you guys are you guys involved with like changes from
we are involved with
cap and all?
Yes, and we are involved in like major aerospace players, and we are doing tests for them. We are delivering them Lpc furnaces. Some of them, they are still to R&D, but this is a first step. And some of them, we are starting to say real production with Lpc at aerospace. So we are getting there, I would say.
To be sure, integrating the technical creation of specs by bringing heat treaters in touch with key end users in the industry is necessary to have standards reflect effective heat treating techniques. Aside from standards, is there any resistance to adopting low pressure carburizing?
I think people are afraid of what is new, and the atmosphere carburizing is very simple and or it's well known. And vacuum carburizing is something different. So for atmosphere carburizing, it's only to control the potential in the furnace and time of carburizing. In vacuum carburizing, it's not that easy. You have to have a special simulator to create a recipe, and people are afraid of it. But they shouldn't be, because there are softwares, and we have a software that can make that recipe pretty easy and pretty quick. So, so people are just afraid of something new. So we have to create a recipe for Lpc for pressure carburizing, and we actually provided. This is our own simulator, and we provide it with the equipment. So it's very, very easy to.
In addition to an aversion to the new and the changes that may involve, folks have a real concern with distortion. Peter then addressed this concern.
So high pressure gas quench in general is better, but there are other methods, and it's not only us, but we all are trying to limit the distortions. We cannot say eliminate, because it's impossible, and but we can try to limit the distortions and control the distortions. So what we introduced to the market is our 4D quench technology, and the fourth dimension is that we rotate the part during quenching.
While there is resistance that may be from outdated industry specs, a suspicion of the new, or technical concerns which industry is continually addressing, Peter was sure to note that there are in fact drivers that are encouraging heat treaters to move towards LPC.
I think the driver is productivity, the safety, and as an example, so Biden administration, he just committed to reduce CO2 emission by 50% at the end of the decade. This is great technology, and there's a lot of CO2 emission out of
atmosphere carburizing.
Exactly. So internal and external. But there will be a push for climate change and CO2 emissions. So it's not only mandates, but I think like in Europe, for example, we have a lot of grants, or like there is a lot of government money you can get if you are reducing the CO2 emission. So I think for the heat treaters, it should be easy to capitalize on it. As I said, no CO2 emission on Lpc. There's no emission at all. So that's the beauty of the technology.
Certainly, financial incentives to adopt greener technologies, as well as a personal desire to do so, would be motivating. Is there anything about heat-treated parts cosmetically that would make Lpc attractive?
Of course.
Yeah.
And you don't have to wash it after which is great. It depends, because we still can have Lpc and oil quench. You have to wash it, but
sure. But if you can get to the gas quench, you've eliminated the wash part.
Exactly, and they are just look nice and shiny and bright. Yeah. So the color is better, and you can eliminate washer.
It is clear that Lpc, one of the factors that plays into the future of heat treat as Peter envisions, has challenges and benefits for heat treaters to consider. Peter then talked about two additional factors for the future of heat treat: automation and predictive maintenance.
There's two other factors. So one is automation, I think.
Okay, yes. Okay.
That's, I think, big, and it's more and more, especially nowadays with the labor issue.
Yeah, right.
But it's to eliminate the human factor and potential I don't want to say problems, because maybe
we understand though, the human error part.
Yeah, exactly. And on top of it, it's the traceability of the parts, and it's more and more customers, they would like no operators, and the machine has to run by itself. And we have the systems, so we have like a full system of equipment. So you just place the basket with parts, or several baskets, and then the robot takes it and takes it to the furnace, carburize, quench, temper, wash, and then it comes out. So
untouched
there's
by human hands.
Exactly, untouched. Exactly. Robots or the automated loader. I'm not sure. Maybe we can call it a robot, but yeah, that is the direction. Yeah? And another is predictive maintenance, what is actually a big deal right now.
Right.
But by predictive maintenance, I mean that the system has to predict the failures or the downtimes, because from a lot of systems which are available on the market, they are called predictive maintenance, but they are like reactive. So, for example, they have sensors on the machine, and if something breaks, it sends you an email, SMS, or whatever. And our SECO Predictive, which our predictive maintenance, is based on an algorithm to actually. So the algorithm is written in a way that the system learns on failures, and and more equipment we have connected to it, more data we have, like everything around right now, the Googles and Amazons and so on, and I think this is the future as well. So everything has to be connected to one database, and just to predict what will happen before it happens.
Maybe an example, if I can ask. Like, let's say you've got a high temperature fan inside a vacuum furnace. All right. How would the SECO predictive maintenance work on that?
I think we would control the vibration on it. I think that's the one way to do it, and then at a certain level, it would send a signal. Watch out! You are about to have a problem with it.
Right.
But it's better to do it that way, because then there is time to order the replacement or schedule something. So it'll not break. But it's the goal is to predict the failure before it happens.
So with these thoughts of Lpc, automation, and predictive maintenance on our minds, we then walked over to a display of various furnaces to see just how SECO Vacuum applied these insights to their own furnaces. Peter began with the Vector, a versatile high-pressure gas quench furnace.
So this is a single chamber multi-purpose furnace. So it's for Lpc carburizing and high-pressure gas quenching. This is the main furnace, and I think 70% of we sell is this. Maybe this is like 50%. Then 20% are the vacuum oil quench furnaces. So vacuum oil quench furnaces. So the heat, the processing chamber is under vacuum, is the same as the Vector, but then we can quench it in oil, or we can have three chambers. It can be like continuous production, or we can have oil quench on one side and high pressure gas quench on the other side. And then we call it Case Master Evolution, because this is the middle step, just as I said, in that goal to go for Lpc, because we still have oil. But then there's another one, the new baby in family, for people, it was not easy to make a switch. So this is like a hybrid, we can say. So the processing chamber is vacuum carburizing, but the quenching chamber is like all the traditional and
just like an atmosphere quench.
Exactly.
Okay.
And it's like a pure replacement. So you can take one out and put this guy in. So you have all the benefits from low pressure carburizing, but you operate it mainly like an old and traditional furnace. So this is to make it easier in that transition. Yeah. Okay.
After learning how certain furnace designs can be helpful to heat treaters who have different processing needs or who are trying to convert to Lpc, we then moved to see how Lpc is being brought to pit furnace size loads.
And this is another one, another tool in our mission, I would say. So this is a pit carburizing furnace, but with Lpc, because right now for big parts and big heavy parts, they are carburized in atmosphere in pit furnaces, and then they open the furnace and they just transfer it with the crane to the oil tank. So this is basically the same, but the pit furnace is with Lpc. So there's nothing like that on the market right now. So we are trying to bring the Lpc advantages to big parts and pit style carburizers as well.
From Lpc for large loads, we ended our tour with an Lpc furnace with an interesting way to maintain traceability.
And this is the single piece carburizing furnace which we talked about. So Case Master, actually, that was the name of our traditional integral quench carburizing furnace in the past, which we no longer do, because right now if we have an RFQ for atmosphere carburizer, we go with Lpc.
Yeah.
There was a video, which we'll include in the episode description below. And I would recommend watching the step-by-step breakdown on how this technology works. It's quite fascinating.
All right, good.
Very well.
Thank you very much.
Thank you very much.
That. Yep.
Thank you very much.
That's all right.
Thank you.
Yeah, thank you.
And thank you.
We hope you enjoyed today's Heat Treat Radio episode with Piotr Zawistowski. Heat Treat Radio is on Apple Podcasts, SoundCloud, iHeartRadio, Podbean, and the website heattreattoday.com/radio. To reach out to today's guest, head over to secovacusa.com or send an email to me and I'll put you in touch. My email is bethany@heattreattoday.com. We're always interested in new Heat Treat Radio topics. Send an email to me with something you find interesting and we can talk about a future Heat Treat Radio episode. Or if you'd like to sponsor a future episode, let me know and we'll be in touch. Again, my email is bethany@heattreattoday.com. HeatTreatToday.com features news and technical content that you won't want to miss. So stop by Heat Treat TV to watch a series of educational and informative videos from around the industry, or search by process, equipment, or industry for all your heat treating questions. Heat Treat Radio would like to thank the Heat Treat Buyer's Guide for sponsoring today's episode. Find your heat treatment resource at www.heattreatbuyersguide.com. This and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advance written permission from Heat Treat Today. Jonathan Lloyd, our talented audio and visual producer, created and mixed most of the music that you've heard today. Check out his professional work at www.jonathanlloyd, that's 2 L's, lloydmusic.com. Thank you, Jonathan. And I'm your host, Bethany. Thank you for listening.